Let me tell you about the equipment we have in the lab. This is a three-phase to single-phase stabilized power supply, all AC. We need this for various kinds of equipment that require very high current single-phase power supply, and this is one of our battery swap stations. Battery swapping is an interesting solution that is getting very popular in India. The way it essentially works is you have a tower in which you have batteries getting charged, and all our batteries are connected to our cloud. So as the batteries get charged, they keep communicating their status to our cloud, and in our cloud we have real-time information of at what location, how many batteries are fully charged, how many are undercharged. In fact, there are other things also we know. We know about the temperatures. We know if the batteries are fitted in vehicles, the vehicles are moving or stationary, each battery, what is the level of charge, and so on. So this enables us to have a real-time inventory of at what locations, how many batteries we have ready to dispense to customers. Now, customers who may be using a two-wheeler or a three-wheeler or a four-wheeler, they get intimated through their mobile phone that their battery is running low on charge, and they are also told what are some of the nearest locations where they can go and change their batteries. Now, when such a thing happens, the user has a choice of swap stations to go and select from. Now, once you have selected the swap station, batteries, depending on how many batteries you need, will be reserved for you. As I told you earlier, we have solutions in which two-wheelers need one battery, passenger three-wheelers need two batteries, cargo three-wheelers need three batteries, and a retrofitted one-tonner truck needs 6 batteries. So depending on how many batteries you need, you will be shown options where that many batteries are available. You select the location, batteries will be reserved for you so that when you go there, you don't have any surprises. You go, swap them one by one, and there are a lot of safety and security features that are enabled to make sure that you are always safe, you are always protected from any possible fraud, etc. So that's the final part of this is entire swapping process. Even for a vehicle like a one-tonner truck, takes less than few minutes. In 2 to 3 minutes, even for a one-tonner truck, you can swap up to the 6 battery modules that you need in that, and you are done. Right? So that's it's faster than fast charging. It is faster than a tach field experience, and that's something that is going to make the users very efficient. And because these vehicles use swappable batteries, vehicles are not sold with the battery, so the initial cost of the vehicle is also very low. And the companies who will run these swapping solutions, they will own the entire inventory of batteries, and they will be offering it as per swap fee or per kilometer pay per use. Business models is what we enable, and it not only brings the initial cost low, electricity being a lot cheaper than oil, cost per kilometer, cost per mile is a lot lower, and so you get the benefit of that as well. So these are something. The swap station that you see here has 4 boxes, 4 compartments. So it normally has 3 batteries inside, and the 4th one is empty. That's where you turn in your battery, your depleted battery, and once you turn in your depleted battery, you will be told which compartment the battery allotted to you is available. The door will pop open, you pick up your battery and fit in your vehicle and get going. We have swap station models that have many more compartments as well. The other popular version is 9 more compartments, but you can build it in any form factor. The only thing that you need to worry about is how many batteries you are going to be charging simultaneously, and what's the AC power requirement for that, and you need to just make sure that you have that much of AC power available. So that's our substation. Now let me show you few other very important equipment that we have. The equipment here is called a battery cycler. So this can charge and discharge batteries under program control at up to 240 amperes. I'm talking batteries, not cells. So we can charge and discharge batteries at really high currents in our lab as per our requirement any time of the day or night. Now, batteries are going to be used anywhere and everywhere. The temperatures could be as low as minus 20 Celsius, minus 30 Celsius, or they could be as high as 50, 55, 60 degrees Celsius. So when all of our solutions, we test them at temperatures that you may encounter in the field. So as you can see, I have an environmental chamber set at 41 degrees Celsius, and there are batteries inside that are being charged and discharged under program control, and we record the rise in temperature during charging and discharging at these kind of ambients. And we have multiple of these thermal chambers of different shapes and sizes, so that we can test even very large batteries. Now, batteries are built using cells. You take large number of cells. Something. This is a cylindrical cell. This is a prismatic cell. They come in different chemistries, different shapes. This is cylindrical LFP68 cell, and you build a battery, a large battery of any arbitrary size, by connecting these kind of cells in series and parallel. So you connect them in series, you get higher voltage. You connect them in parallel, you get more current capacity. So that's how you build batteries. And of course, once you have done this series and parallel connection, you need to make sure that the battery is managed well, so that you never overcharge it, you never over discharge it. You keep the cells balanced. I'll talk about that concept sometime later. But all these functions are taken care of by a piece of electronics and software called the battery management system. So we do have our own BMSs as well. Now, once you have built the battery, you use a battery cycler to charge and discharge them. But before you build the battery, you use a cell cycler, and we have multiple of them. In the other corner of the lab, you'll find the 96 cell cycler. This is a 48 cell cycler, and this the 48 cell cycler can program, can charge or discharge up to 48 individual cells, where each of them can have a different program. So you could be charging one cell at maybe 30 amperes, and you could be discharging another cell of a different chemistry, different type, at maybe 10 amperes. You can do this at different temperatures by keeping them in different thermal chambers, which may have been maintained at very different temperatures, right? So, and all connected to the same machine. So there are a lot of these interesting things that we keep doing. There are many other equipment. Earlier I talked about swapping solutions, swap stations. This is another model of force compartment swapping machine. We have here that is a 9-slot swapping machine. This is for one of our customers, DSR EV Mobility. They are going to be launching this solution in Bangalore. and they plan to have 350 locations right in the beginning. And in a city like Bangalore, if you put 350 locations from anywhere you are, practically within a kilometer or two, you'll have a place where you can swap. Okay. So as I said earlier, we have multiple thermalcyclers. This is another one. These are 96 channels, individually programmable. So you can charge and discharge up to 96 different cells under one program control, and each can have a different charging discharging regimen. There are a lot of other equipment we have. For example, this is a spot welding machine. For connecting the cells in series and parallel, you need to connect them using nickel strips. Now, cells can get damaged if you heat them. That's why they're not heated. You use a spot welding machine where a very high current, you see the size of these conductors. What happens is for a few milliseconds, you supply several thousand amperes to that point, and the metal melts and makes a permanent weld joint. But the amount of total heat is so less that although you had a welding done at that spot, the moment later you can actually touch it. It won't be, it doesn't create too much of heat. It's just high temperature, very localized. So, and then we build chargers, we build battery management systems. One of our items that is very popular is something called a telematics unit. Let me show you a telematics unit. I can show that to you connected to our battery. So these are our telematics unit. What they do is they connect the battery to our cloud. So one interface in this telematics unit is CAN or UART or serial interface, and the other side it connects to our cloud over the cellular network. We have several other pieces of electronics that go into the whole solutions. This is a display. It is right now displaying the state of charge of the battery, and it is telling you the average temperature, the voltage of the pack, the highest cell voltage, the lowest cell voltage. So that tells you how well the pack is balanced inside and so on. The other interesting thing is this thing is capable of creating an audio-visual alarm if there is anything wrong with the battery. For safety and for regulatory reasons, both are required, and this piece of electronics gets embedded in the battery to do that. We have several other interesting solutions, and as we said earlier, we are chemistry agnostic, and what that means is while we work mostly with lithium batteries, lithium iron phosphate, NMC, all other chemistries, we also work with lead acid batteries, and lead acid batteries are very, very cheap. They're very cheap, and in stationary applications they are still very popular. The total number of lead acid batteries being manufactured in India every month is at least 5 million. So that's the volume of lead acid batteries, and so some of our technologies we also serve that market. For example, we have a solution to keep them charged in a balanced manner, which is very, very important, because if the batteries are not balanced, or batteries connected in series are not balanced, all the batteries in that series connection can go bad very, very soon, and that can be an expensive affair. So by keeping them balanced, you actually enhance the life of those batteries. So we have those kind of solutions. Some of the best known names in India, battery manufacturers, use our solutions. We have something called a smart battery sensor, and the smart battery sensor is getting very popular because it gives you real-time measurement of the voltages of the multiple batteries that may be connected in series and fitted in your vehicle or UPS system and so on. Now, if the batteries are not balanced, okay, if they are not all of near identical voltage, you would get an alert. And to do something about that, maybe balance them manually outside of that circuit. And of course, we also have chargers that will ensure that even your series connected bank of lead acid batteries stays balanced all the time.